Claire. Today we're going to talk about section 3.2. Tomorrow you're going to have a graded assignment.
Oh no!
Are you serious right now? Okay.
Said so.
I was just repeating what Mary said.
Okay. So today's goal is for us to be able to tell the difference between a linear and a non-linear function. Linear. What does that make you think of? A line. Very nice. So a linear equation in two variables, okay, is going to look like this. Y equals a number times X plus a number. Basically, both X and Y have exponents of 1. Okay. For example, y equals 2x minus 3 would be a linear equation.
Option is a special
type.
That's big.
Yes. If both x and x plus 1, why is y of anything next to it on the equation?
So we wouldn't write the exponent if it's 1. So we're talking about exponent, like just say exponent.
No one can answer.
Didn't we have questions like that on the
Why?
I don't know what's on the homework either.
Yeah, I know.
Okay. Now, graphically, a linear function is going to be a non-vertical line. Like maybe it has a positive slope, maybe it has a negative slope, maybe it has no slope. What one do you think is positive? Okay. Something that is important to understand is that a linear function has a constant rate of change. We are going to talk about that a lot in the coming weeks, but a linear function has a constant rate of change. That's why it is a line.
What is TV?
TV what? To be graded. Obviously not up here. Okay. Hey, what do you think a nonlinear function is? Not a line. That would be nonlinear. Lines are straight.
Wait, what about the infinite sign?
Use the line.
The infinite sign.
It's a curve.
But so does the circle though.
Yeah, a circle is a curve.
So it's non-linear, right?
Yes. Okay, now I do need you to make a note that a vertical line looks like this, and its equation, all lines are straight, and its equation is x equals a number. Because you said it's a straight line.
I was just putting out. I'm gonna know.
Stop trying to be a smart
Not
aleck.
the main character.
The world doesn't revolve around you.
The scientists.
I think Noah's studying the apple.
Some people are gonna be surprised that they're not.
You share this down?
Wait, what?
That's a good one.
That was the quote.
Wait, was it? Oh, was it that?
What?
I think Noah's
I
studying
thought that
the apple.
Okay, turn the page or go to the next page. I don't know if you have to turn it. I don't know if you heard Connor's comment, but it was pretty spectacular.
You want me to read it again?
Yep. Okay.
What is it called?
When scientists discover the center of the universe, some people are going to be surprised that it's not them.
We could go walk down the steps right now.
I think that's.
It's really what?
All right, buddy. Later,
Man. Well, props to Mr. Claire. That's a good one.
Mr. Claire?
Truffles. You said STEM.
STEM is Mr. Chocolate.
STEM
enrichment is Claire. No, STEM enrichment is Chocolate.
Mr. Claire is robotics.
That's what mine says.
Sorry. All right. So here we go. This guy right here. This is a linear equation because it has a y and an x. They both have an exponent of 1, and they are not being multiplied together.
Why does exponents matter? What's linear?
Wait, so exponents, so like if you put a 2 and then a times 2, it's not linear.
So if it was y equals x squared plus 3, that is not linear. Because it's not in one dimension. Yes.
I'm like, I see this in the real world.
I don't know what you're gonna be when you're gonna grow up. So okay. So now the whole purpose of a linear equation is that we have a constant rate of change. Noah, this may be annoying to you, but the concept of rate of change is one of the most important things that we're going to talk about in this class, especially if you're going to go take calculus, which a majority of you will. That's the trajectory that you are on.
I'm taking calculus too. Unless you like to take it.
Okay, so Kyron, how do I get, so -1 to 0, I go up how many? 0 to 1. 1 to 2. Right now, my x's have a constant rate of change. What about my y's? 2 to 3.
1.
3 to 4.
1.
4 to 5.
Yep.
So since we have a constant rate of change, this is a linear function. And guess what? Because it's linear, it makes a line. Wow.
You forgot the E.
That's
That's an N. For the
I'll
N.
do the N house of another name. W, and you stop trying to be smart.
Bricks was the other word for that. There we go. That's we do it right there. It's all right. We do it right there.
All lines are straight.
You should get a shirt that says that.
Okay, now I want you to turn the page and I want you and your partner to decide if number 1 and number 2 are linear or non-linear.
What do we know?
Number 1.
Turn the page and do number 1 and 2 with Allison.
The second one is not.
It's really easy. I think.
I don't want to. The second one is not.
I said that.
What?
I think you need to check your.
Gross. You need to lock in yourself. Hey, lock in.
Eli.
Brooks.
Guys, my
Come on.
arms are on you.
Can you look at number 2 again?
All right, eyes up here. Reese, what do you think about number 1? This is not straight,
I know it.
not a line. It's non-linear. Mine?
Oh, Rashi.
Oh, ramen. Okay. Brooks, is this a line?
Yeah.
Yeah, it's a line. All right. Now let's look at the tables. Number 3, do we have a constant rate of change? I hear yes, I hear no. Okay,
So,
No.
1 plus 3 is 2. 2 plus 3 is 5. 5 plus 3 is 8.
That's constant. No.
that's constant.
Walk it in, Noah.
4 plus 37.
Walk it in, Joe.
Okay, so here's the deal. The x's are constantly going up by 1. The y's are constantly going up by 3. This is linear.
Let's go.
Number 4 is done. I said 4.
We have a constant rate of change, so this is linear. Okay, so figure out number 4 for me then.
It's not right.
Just let other people look at it too. Some people are like with me when I'm talking instead of moving ahead.
I know.
I was too. I just as soon as you said solve it, I'm not.
Like, it's not a very hard process.
It really is.
You see the 2 zeros. You know, yeah, like you know something's up.
Hey, Anders, that's not
You see those zeros. Beggars.
What? Huh?
Alright, bro, is it linear or not?
Yeah. Also, what's the rest of the class? Wait.
Good.
Ian, is this linear or non-linear?
This is.
This is non-linear. Henry, is there a constant rate of change with our x's?
Yes. By 1.
You have my, those are the X. Oh,
After I sabotage.
But the y's are -1, +1, +3. This is not constant, so it's not okay. It can't be a pattern.
Has to be constant.
Wait,
But it's
is the
constant.
constant change
No.
the rate of
No,
change?
it's constant
Graph?
Okay. So, Ian had a good question about this like constant rate of change and what it looks like on a graph. So I am going to come up here on this number 2 graph, and I'm going to graph 1, -1, and 2, 2, and 3, 5. That's about all I have room for. Okay. So what do you notice? Okay. So do you notice how we have like the up 1, up 1, up 1, up 3, up 3, up 3? So here is like the 3 and the 1, 3. Yeah.
Oh, yeah, that makes more sense seeing it on. Wow.
That does. That's a lot.
Okay. Allison, do you think that number 5 is linear? You would be correct.
Yes. They don't walk it through.
Okay. We know that this is linear. X and Y have exponents of 1. We can rewrite it into y equals mx plus b if we wanted. Okay.
I can answer the second one.
I'm sure you can, but I'm not going to ask you to. I am going to ask somebody that's not named Kyron. Ethan? No, this is non-linear. What's the giveaway? X cubed. Not cool. What are you eating? Okay. Henry.
That is a distraction.
Henry, I talked to you about
Kyron, I need you to tell me which one of these is discrete and which one of them is continuous.
Oh, you better get that thing on my calendar.
The continuous one would be number 7, and discrete would be number 8.
I do not.
Harry, how does he know?
I don't know. I can tell.
I don't want you to tell me. I want Harry to tell me.
Uniform friend?
Not Kyron.
Louise.
I got you.
No.
Ain't no but that kind of. No, now besides me.
Kari.
It's a discrete.
Okay, we have a finite number of dots. She said multiple. We can actually like count them. How many points are on this graph?
2.
Not 2.
Well, actually infinite.
Infinite. There's
No.
an infinite number of coordinates on this graph, so it's continuous. And this one is discrete.
Discrete.
This is one of our vocabulary words from yesterday.
How are there infinite number of dots?
I'm a big because you can go 3.1, 3.11, 3.11.
This is a dot, this is a dot, this is a dot.
And you go in between each other infinitely.
Yeah.
You have infinitely small numbers.
It's uncontrollable.
Okay.
Well, yeah, the decimal point.
So you know what? I am really looking forward to a little bit of quiet while we work on our homework.
Yay.
Yeah.
Wait, why do we have to do so much? Do we have 5 through 30 on this one? Is it like 5 through 30 odd, or is it 5 through 35? Or 5 through 30 odd?
So I'll tell you right now, this is already loaded in Google Classroom. So you can either look up here or you can look up Google Classroom.
Last 5 through 30 all, or just 5 through 30 odd?
All.
5 through what? Odd through 30
Oh,
30?
it's linear, non-linear. Linear.
If I count, that's about 10 problems, 10, 12 problems.
Bro, we have 20.
5 through 30? You want to try that again? No.
It's more?
Wait, we have 25 questions? No.
Yeah.
What?
I said that during advisory.